So let's go ahead and get started. Our feature webinars again, MCAD Collaboration can make you more productive. So just a couple introductory slides here, and I'm going to spend most of my time actually in the tool talking about stuff. And that is, Siemens is very big, and the industry is starting to shift more towards the process of using the digital twin philosophy, where you don't just build something in a CAD tool or design something in a CAD tool and then physically go build it to test it. The philosophy of digital twin is that everything you do in the CAD tool, you should also be verifying that process in the modern CAD tool for using simulation, or like what we're doing here, using electronic tools to transfer data back and forth. You know, in the past, people use paper drawings to do the things that we're going to be talking about here today. And obviously that does not have to be the case anymore. So the process of using more and additional or higher level software to analyze your designs or to communicate between different platforms within the design process is something that is going to take over the industry. If you're not already joining in and using more simulation and trying to do more electronically instead of just building and testing and then going back and fixing, you should definitely be looking at this philosophy of design. It's going to be much faster and far more cost effective. This also includes PLM, or product lifecycle management data. You know, being able to store all that data in a centralized system and have it communicate between the tools is another big piece of the digital twin philosophy. So if you're not using a product lifecycle management tool out there today, I would seriously start looking at doing something. There's a couple tools that we represent, Omnify and Siemens Teamcenter. So let's move on to the main topic of today, and that is MCAD Collaboration. So really, what is it? It's just the ability to push and pull data between your mechanical engineering tools that your mechanical engineers might be using and the PCB layout tools that you're using. Now, I don't know. We may have some mechanical engineers and some electrical online. Hopefully we have both. So both of them get a little bit of flavor of what we're talking about here. But it's a much better or more streamlined way of moving data between the two applications, because now you don't have to deal with the old methods that we've all dealt with, for those of us that have been designing for a long time over the years, either DXF files, which just come in as dumb drawings. Then you have to, you know, kind of copy or replicate what's on that DXF. IDF was a big step forward, where you could at least start bringing in some intelligent data from an MCAD environment. Most MCAD tools out there do support outputting IDF data. And then STEP started to come into play. More and more tools started supporting the STEP modeling capability, which PAD started doing several years ago as well, for generating a three-dimensional realistic view of the board that you could bring into mechanical. Now you could start doing a little bit of clearance checking with that as well. And then, of course, there were paper drawings. But the collaboration continues to go a step further, okay? The Mentor solution and some of the other vendors out there are all based on an industry standard. PTC actually started the IDF standard many, many years ago, and they've migrated it forward, and it's kind of taken off into its own organization now called ProStep. It's basically a very modified version of IDF. It's doing kind of the same things IDF was, where it's not like DXF, where everything is stored in, you know, everything about a design is stored in one big file. IDF was meant to be very centric to electrical engineering data that a mechanical engineer would find value in, and vice versa. So being able to draw a board outline, put mounting holes in, keep out areas, place components, and have that information pass into electronic file into a layout tool where you just import it and your board outline automatically gets created for you. Some components can get placed, mounting holes can get placed, hopefully everyone on this call is taking advantage of this. I still meet with customers today that are kind of doing it the DXF method. I really haven't talked to anyone doing paper drawings, but I'm sure there's some out there that are still using PDF drawings to replicate board outline and component location information. If you're using some service companies for mechanical engineering, I guarantee they have the capability of producing IDFs. You just need to push on them a little bit if they're not willing to give you that information. So again, the ProStep file format is a little bit different. It's not IDF. The file formats are called IDX or IDZ files. And the data that's inside of them, unlike IDF, which is just text, is more XML formatted. So a little bit more information in there. That's the nice, probably one of the biggest things that was added with ProStep is the ability to put notes in there, who the designer is. You can keep track of changes as time goes on. You'll kind of see that when I show the collaboration tools here. So let's go ahead and take a look at what the tools actually look like. So I'm gonna go ahead and open up pads here. So hopefully we've all seen pads and its ability to do the 3D stuff. That's what I'm showing here. This is a simple board design that I put together, and I've placed the components. And then over here in our 3D view inside of pads, I'm able to view the board with real 3D geometry. I've even imported, oops, I didn't want to do that. Let me go ahead and close that again. I've even imported a mechanical enclosure that I created for this design, and you can place that inside of your MCAD tool like pads, and then play around. And well, first of all, you have DRC capability. So if I go up here to DRCs, I can actually create three-dimensional DRCs against particular component classes or just anything in the design and do actual DRC checking in 3D space. This type of stuff most MCAD tools can't do, so it's actually kind of nice when you're really getting into tight design that you actually do take advantage of the pads functionality to do three-dimensional viewing and DRC checking. By the way, the DRC functionality is currently only available in Pad Standard Plus. If you're using Pad Standard, you still have the capability of importing 3D models of components and enclosures. You just can't use the DRC function to do any verification for you. So, so again, hopefully everyone's taking advantage of this technology in the tool. I'm going to take a chance here, a moment here, just to show you again some new technology that was added in version 2.3, and that is how you can go about assigning models to parts. There was new technology added there. I go ahead and select the part here in the layout and then do edit decal. This will take me into the decal editor. And you'll see these big green arrows are popping up now on my screen that weren't there before previously in versions earlier than 2.3. Okay, but the big enhancement here is the ability to just click on an arrow and have it automatically rotate the item for you in any direction just by clicking on it. You don't have to manipulate it yourself. And then these two buttons here have been added to the tool. So if I was to select this component and move it up in the Z direction, say 50,000. Oh, that was a little bit too high maybe. Just go up 1 millimeter. There we go. Much better. All right, so instead of me having to worry about coming in and figuring out what the right number is to mate that item, I can do mate seating plane. Then I can pick the bottom of the pin and it will automatically snap to the top geometry of the pad. And then there's also a center alignment function where I can select the pin and it will automatically snap to the center of the pins. So no more having to manipulate numbers to align parts in the decal editor or rotate and such. It's very quick and simple to do that now. So then anytime you've made modifications to a model assignment or you've added a model assignment, the tool is going to ask you to update your design. I'm going to go ahead and cancel in this case. And if you're using integrated flow, you can actually store all your 3D library content off into your library by coming up here and going update library. And any parts, new parts that have models assigned to them, you can now send those off to your central library so that every time a new design comes in, you can update it very quickly and not have to go through each unique component and merge items. So just an FYI on that one, so everyone knows you have that capability. Now let's get into the collaboration side of this a little bit. So in VX 2.3, everyone now has a license of the collaboration tool. Up until this version, this was a pay-for option. That is no longer the case. If you are a collaboration customer, just know that when your support comes around, you can go ahead and drop that off support because it's now included with your PAD Standard or Standard Plus or Pro licensing. All right. To activate the collaboration function, you come up here. You have to be in the 3D view to do this, and it's the very last button here on the top toolbar. You go ahead and click that, and it opens up the collaboration dialog box. All right. Go ahead and maximize this a little bit here so you can see a little better. There's a couple different sections here. There's files that are currently being worked on or in collaboration between you and the MCAD engineer. And then there's the history. This is a function that you could not do with IDF previously in the past. Plus, one of the big differences between IDF and real collaboration is you can do incremental changes. With IDF, it was all or nothing. Mechanical engineer would output an IDF file. If you were already working on the board, you couldn't necessarily just bring in the IDF file because it would possibly move stuff that you already had routed or something like that. With the collaboration or ProStep interface, it's like an ECO between the schematic and the PCB. In other words, the file, the IDX file, only contains things that changed either on the MCAD side or the electrical side, okay? So that's why there's a history section here, is that it keeps generating new files with a new naming structure like 0, 0 or 1, and then it goes to 2 and 3 and 4 and 5. But you can always go back and see what else you've done in the past by looking at it. The other great feature of the collaboration tool is if, say, the mechanical engineer moves something, before I make that change in my design, I can view it. So when I open it up and see the change over here, I can click on the part and I can see where it's actually moving to versus where I have it currently placed. That gives you the advantage to use this little abandon button down here, or actually a rejection notice, to where you can send a rejection back to the mechanical engineer, and you can reposition or suggest a minor change to his placement position, or just reject it altogether and let him try again. And that's all done via a note down here in the bottom in the properties section, okay? Now, to make the whole collaboration stuff kind of work from the get-go, you need to come into setup. This is the first thing you need to do when you come into the collaboration tool, is you need to go into the setup section, and you can set the schema. Either one is supported. That was more dependent on the mechanical engineering tool. What units you want to output your change files in, and then what file naming structure you want to use, straight up XML, IDX, or IDZ files. Is this going to be an email-based or file-based system? Meaning, down here, we can point to a particular location where all the change files that get created end up going. The nice thing about that is if you're in your collaboration tool, you're notified right away that, hey, someone's put a change file out there. Let's go take a look at it real quick and find out why. And the MCAD engineer sees that change as well. If you do it email-based, what you're doing is when you send a proposal for a change, that change is going to go via an email, and then they'll have to save it to their system and update. So you lose a little bit of that almost real-time type notification that a change has occurred when you use the file structure. So you can store the file, that pointer can go anywhere on the network or on your local system, it doesn't matter. More likely with in a company where two people are working on a project, it's going to be a network location, but that's probably the best method for doing things. So you have a little bit of control over what's included in the IDX files. You can output mounting hole information, pinhole information for through-hole components. You can also have it output pad, trace, and via, copper geometries if needed. Just remember that starts making the data that's being imported into the MCAD tool quite large, and therefore it's going to take longer to upload. So typically pads, traces, and vias aren't really a requirement, but the mounting holes are definitely nice, and sometimes the through-hole pins for components can be nice to see as well. All right, you can specify a generic geometry.height when you output the file, just in case you have some parts that don't have geometry.height information, or if the MCAD engineer hasn't created or assigned step models to the same part numbers that you're using over in his library, so that when the IDX data comes over, a model will automatically be pulled from the library. So that's currently one of the things that does not happen is if you've assigned step models in your layout tool and then you pass over an IDX file to the MCAD engineer, the step models are not going with that. Right? They will have to have the models in their library so that when it comes in, it will automatically go pull that model. The other thing is that your naming convention does need to be the same, but you can assist the mechanical engineer a little bit in that by having 3D models in your library. What you can do beforehand of using the ProStep interface is you can use our export of step models. So if you choose all mechanical models here, so I'm going to output a step file, you point to where you want it to go, what the name's going to be, but you choose all mechanical models. That means you're going to output a step model of the board, and you're going to output all the step models that you've placed in this design. That does help the mechanical engineer on his end if he wants, to really see all the components in their MCAD environment. If you've already done all the work, you can just pass them a step model of that design, and they'll get all the data. They can store it off into their library. The nice thing there is it'll come with your naming convention and your origin point data as well. So this is also this is also a great feature for you to if a mechanical engineer wants to generate any pretty documentation for whatever reason, you can send them a step model of the board so they can generate that type of documentation out of their tool. All right, back to the MCAD environment here, or the collaborator. So again, down here at the bottom, you need to specify a file path of where you want all of your file-based sharing to go, okay? And then anytime you generate a proposal or a baseline design and you send it over, it will go into that location. You can add information about yourself in here if you want as well. If you happen to be working with someone outside the company, that might be kind of nice to have. But that option is there as well, all right? So typically how the collaboration starts between the two environments is either the mechanical engineer is going to create the board outline and place some parts, put mounting holes in, and he's going to do what's called a baseline design output. So he'll choose that in his tool as well. It'll gather all the information that he has on the board and any electrical based components, he can put some notes in on what his base design is like, and then he can, let me go ahead and abandon the change here that I was working on. He can go and send out that IDX information. So this will generate the output data that they can then bring into their MCAD environment. All right. In this case, mine's going to my collaboration folder here. And you'll see there's the one that I just created. It is rather large because it's including every single part, location, and information in the design. Okay. And now if I go over to using Flowtherm XT in this case, which is based on SolidWorks engine, and it includes the collaboration functionality in there as well. So I can come up here to open. Actually, let's just start an assembly real quick. And then we'll go to the CircuitWorks interface, that item that pops up, and we'll do open an ECAD file. And I'll go choose that IDX file that I just created, hit open. This will pull the data into the CircuitWorks interface for SolidWorks. Okay. And then from there, you can generate the board outline information. So if I right click over board outline here, I can say build a model based on what I have brought over or pushed over to MCAD. This will generate that board outline model. There it is. So there's the exact board outline that I just was showing you in PAD's layout. All right, with mounting hole information. All right, and then after that, you can go ahead and push over. I'm not going to go through the process of doing this because it takes a little bit of time, but you can go ahead and build a model of the entire board. So it'll take all the parts and everything and push that over as well. So now what the mechanical engineer can do is he can go move an item or change the board outline, move a mounting hole, add a mounting hole, move a component, add components, and then he can come back to the EDM tab and do a sync with EDA. And what that will do is that will then generate an IDX file from the MCAD environment that can now be imported into the ECAD environment. So I just happen to have one that I will just copy into collaboration folder. And if we go back to our collaboration tool, you'll see it instantly showed up that there is a change pending. When I clicked on it, it shows me that, oh, J1 moved. And if I clicked on J1, I can come down here into the properties section and I can see, you know, where the dimensions are for it. And then, like I said, you can apply that change to your design, and you'll see that connector right there just jumped over into a better location than I placed it based on the mechanical enclosure that this is going into. All right. Now, from that point, I can continue to make an adjustment if need be. So if I minimize that a little bit and I go look at, let's see where they ended up moving it to. That one actually looks pretty good. I should have used a different one that was a little bit closer to the board edge, but if they ended up pushing it too far forward, not knowing that there were copper pads here, I could then make an adjustment to this part. Well, let's just do this. Let's not even do that. Let's go to properties here, and I could move this part back a little bit further. Let's go to 35, bump it back a little bit. Now I can go into my collaboration tool again, get data. It will now have an update in here for the new location information that I sent, and I can say, you know, had to move 0.01 inch for assembly reasons or something. All right, and then I can send that off. And now that ends up down here in the history. And if I go back over to my MCAD tool, you'll see if the mechanical engineer was still up in CircuitWorks, it will let them know, oh, you have a pending change that just occurred. Let's go ahead and pull that in. And then I could do that change and see what, you know, if I want to accept that update, or if I want to, you know, make another suggestion, or then we can hash it out a little bit more as to maybe we should make the board a little wider or something, or choose a different connector to make it work for our needs. So that's the basics of collaboration. The big thing here, hopefully, that you've seen is that you're moving data back and forth between the MCAD environment using electronic information. You're not having to worry about dimensions, go type in dimensions and where to put stuff. It's all done electronically with a couple of clicks of a button in the cool tools that you're used to using. All right, so that's all I had for the day. Thank you for joining another Did You Know webinar from Oasis Sales and Trilogic.